Okay, question number 1. What is the total area under normal curve? Let me explain to you what means normal curve. Normal curve is this, bell-shaped. When do we have bell-shaped? When we have evenly distributed database, 100%. Okay? Well, approximately 100%. And this 100%, portion-wise, it's going to be 1, right? So the answer is going to be 1. Checking. Next question. So what requirements are necessary for normal probability distribution to be standard normal probability distribution? So what is normal probability distribution and what is standard probability, normal probability distribution? Normal probability distribution, I just said a minute ago, it's when data are bell-shaped, okay? They are symmetric. When mean, median, and mode are equal to each other. Standard, when we are standardized, since data can be enormously large, to be able to make it easy to work, we make it standardized. So, for example, actually I will put the lecture underneath, okay? I'll put the lecture so you will watch it. I don't want to now lecture. This is for homework to complete. Okay, the mean and standard deviation, they have to have value. Mu is 0 and standard deviation is 1. Oops, mu is 0, standard deviation is 1. Here it is. So when we are standardizing, let's real quick. This is value of my x or whatever value it is. I'm going to standardize and represent by z score. You will listen the lecture, you will know. So if the average here is 100, so when I'm standardizing average, which is mu, average of population is 0. And standard, yes, let's say standard distribution here is 24. Here a standard distribution gonna be something else, but for standardized case, it's gonna be 1. Okay? But you need to watch the lecture so you can make sense out of this. Okay, fantastic. Next one. Determine whether the graph shown could represent a variable with normal distribution. Absolutely not, because the data are skewed. See, it's not bell-shaped. So explain the reasoning. If graph appears to represent a normal distribution, estimate the mean and standard deviation. It's not appear to be normal distribution. The data are skewed. So which one is going to be the answer? The graph could not represent a variable with a normal distribution because the graph is skewed where? To the left. Yes? This one. This will be skewed to the right. This is skewed to the left. And in our case, it is skewed to the left. And normal distribution, this is normal distribution when it's a bell-shaped. Next one. So, how about this one? Does it represent normal distribution? Absolutely. This is normal distribution. Yes, the graph fulfills the properties of normal distribution. The mean is approximately, let me see, 20, 21, 22, 21, I would say. I would say 21. We'll see. And the inflection point about at the point of, let me see, 17. Inflection points, let me explain to you. This is inflection point. That's where it's trying to going straight but in heading down, right? Taking a break to go down. So in this case, inflection point, I'm looking, it's going to be 17 and 23. So I would say free. Difference between 17 and mean 20, it's free, and 23 and 20, it's free. I would say it's free. Oops. Excellent. All right. Next question. Question number 5. So what do we have here? So determine whether the graph shown could represent a variable with a normal distribution. Does it represent a variable with normal distribution? It is symmetric, but it's not a normal distribution because these tails are going below the x-axis. Okay? Therefore, we say that the graph could not represent variable with normal distribution because the curve crosses the x-axis. All right. Next. Question number 6. Okay, what do we have? Find the indicated area under standard normal curve. Z is equal negative 0.76. Okay, guys, you have to listen the lecture so you would understand what it means, okay? In the meanwhile, this is how I'm going to work. This z-score, I have one is with positive, negative z-score. See, we have also negative z-score. And here we have also with positive z-score. So if z-score given negative, I use one table. If it's given positive, I use another table. So since it's negative, I'm looking for negative 0.76, I understand, negative 0.76. So z-score I'm going to find vertically and this horizontally. So 0.7, I'm looking in the first line, see it's a bold number, 0.7 right here. So now I'm going vertically to find, because I have 0.76, I'm going vertically to find 6. Here it is, 0.06. Going down, 1.76, I think it's 0.0392. So negative 1.7. And it comes to 0.0392. Let me go up here, 0.0392. Let me try. I'll explain this. 0.0392. Let me try. That's incorrect. Okay, I guess it's something I messed up there. But let me explain real quick how we are working with z-score table. Okay, so here we have table, z-score table. One is with positive z-score, the other one is negative z-score. So this is negative z-score, assuming. So z-score consists of two decimal notations. This I put xxx, just positions. So the first whole number and first decimal located goes vertically, and the 0.0x, this second decimal, comes this way. Let me, and intersection is going to be your number. For example, let's say we take 0.76. Yes? So negative 0.7, I'm going to find somewhere here, negative 0.7 vertically. And the 0.06, I will find horizontally like this, and their intersection will give me probability. So let's go back, see what we messed up there. So we need negative 0.76. Let me open this one. 0.7. Let's see, 6 in which position? Starting 0.09, 1, 8 is 2, 7 is 3, fourth column, right? So 0.7, and I'm going 1, 2, 3, fourth column. So it's going to be 0.2236. 0.2236. Okay. 2236. Okay, good job. Moving to next one. So here we have negative 2.52. Again, negative. So I'm looking 52. Where is my 2 horizontally? This is the last second decimal. 0.02, it's a third column from the back, right? 0.00, 0.01, 0.02. So, and vertically I have to find negative 2.5. So here it is, negative 2.5. And I'm going to 0.02. Let me see. It's going to be 0.0059. 0.0059. Let's see. 0.0059. Nice work. Next, positive 1.36. Let's see what we have here. 1.37. So, oh, this is negative. I need to open positive one. 1.3, it's right here, and 7 is going the third column from the back. 1.3 and 7, 0.9147. 1.3, 0.9147. So I have all these in details explain. Okay, well, let me see what we missed it. 1.37. Okay, 1.3. 6, 7, 9, 1, 4, 7. Okay. 0.9147. Okay, what did I have? Yeah, I had it. 0.9. To the right. Okay. Okay. Here is the thing. Let me explain. All this z-score that we are finding, it shows the area, let's say, to the left. Okay, this table always shows the area to the left. In this case, it was asking me to do to the right. See, it says to the right. If I go to previous one, see, it says to the left. So when it says to the left, we can go look in the table and the result will be correct. But when we have to go to the right, which is in this case, and I have all this explained in the lecture. Here, I'm just real quick. When we need to do to the right, for 1.37, let's say this is 1.37, from the table of the data I take, it's going to be to the left, the one 0.9147. Now, but we need to the right. So what we're going to do, we know the entire area is 1. So we take 1 minus 0.9147. So 1.0000 minus 0.9147. 10 minus 7 is 3, 9 minus 4 is 5, 9 minus 1 is 8, and 0, 0.0853. Let me double check. 3580, 0.0853. So 0.0853. 0.853. See? Fantastic. Okay. Now between z score is 0 and z score is 2.87. So how to explain that one? When we need to find the area between, so let's say, how much was it? 0 and 2.87. Okay, 0 here is 0 and 2.87. So I'm going to find the score to the left, let's say this one. Okay, and then I will find this score to the left for 2.87. And once I find it, both of them, I'm going to subtract from each other, and that will give me this area between them. Because this piece minus this piece, it's gonna give me this area, right? Okay, so let's work on it. 0.00. Here it is, 0.00, it's 0.5. Why? It's always, this score equals 0, it's going to be 0.5 because 50%, when it's normal distributed, it's split into 50-50. So 0.5. And now we need also 2.87. 2.87. 7 is going to be third column from the back, right? Backwards. 2.8. 8 and 7, 0.9979. 87. Yes. So 2.87, 0.9979. So what do we have? 0.9979 minus 0.5. And we get 97940.4979. Let's see. 0.4979. Okay, what did I do wrong again? Some numbers I'm messing up. Hold on. 2.87. I'm kind of in a hurry, and it's 8 and 87. The 7 is the third line, third column, 987. Okay. So 2.87, it's 9979, and 0 is 0.5. Well, that's okay. So we are doing everything right. 9979 and 0.5, 4979. Well, 49, decimal, not point, not comma. Excellent. So moving to question number 10. So it's going to be the same. You need to find between these two, right? So let's work on it. So negative 3.02. Since it's negative, I'm opening first one. Wait. Okay. Negative 3.0. And 2 is going to be almost at the end of the third column. 3.02, it's 0.013. Let's write down real quick. 0.013. Did I write down correct? Let me pay attention. 3, 0 to 0.0013. Okay. Okay. Now, positive 3 point, let me see, let me close this one. So I'm opening positive one now. 3.0 and 2. Where is my 3.0? 2 is 1 to third column from the, counting from the beginning, right? 3.0. Okay, and 2, 0.9987. 0.9987. So, seven minus 3 is 4, 8 minus 1 is 7, here is 9, here is 9, 0.9974. Zero point 9974. Well done. And so on. Now it says greater than z-score, greater than 1.9. So greater than, that means it's looking on the right side. So we need to subtract, right, from 1 once we find the score. Okay, negative 1.91, negative 0.01, it's second column from the back. So in negative 1.9, here it is, incoming second column, it's going to be 0.0281. 0.0281. Okay, and since it's asking for probability for z-score greater than 0.0281, that means it's asking for the right side. So we have to do 1 minus 1.000 minus 0.0281. It's going to be 9. 9 minus 8 is 1. 9 minus 2 is 7. This is going to be 9 here left, 0.9719. Excuse me? No, I'm not COVID. So one more time. 9719. So 0.9719. Excellent. Next question, number 12. So it has asking for left. Okay, I have to go to school right now. We have starting class, so in an hour. So this is question 12, 13, 14. I will finish it tonight, okay? All right. Thank you for watching.